So hi everyone, and thank you for attending this talk. So in the next 25 minutes or so, I will present you how to build powerful chatbots with the use of natural language processing. My name is Renaud. I'm a software consultant at Zenika. Zenika is a consultancy company. We deliver software projects, technical expertise, and trainings. And for the past couple of years, we now have a presence in Singapore. As for myself, I've been working for the past 10 years or so in Paris, London, and Singapore, mostly in the finance industry. So either building trading platforms for big investment banks or helping small fintech startups deliver the application. So first of all, a bit of context on chatbots. So I guess you could say that they have been around for quite some time now. I remember a couple of years ago, they were really at the top of the Gartner hype curve. They were quite trendy. I guess now they are a bit more settled and mature technology. So back in 2016, a turning point was that Facebook Messenger, they started opening their API to developers so that anybody could easily create a chatbot. And in the following 6 months after that, there were more than 30,000 chatbots listed on the platform. Actually, a year later, it went up to 100,000. So yeah, it was quite popular. Just a sample example of what you can achieve with Facebook Messenger. This is a flight booking application for airline company. Yeah, my definition of chatbot is a bit large. I'm talking about either something that you interact with through your chat tools, like WhatsApp, Slack, or WeChat, or something that you embed in a website, like for customer service, or even things like Siri or Google Assistant or Alexa, these kind of things. All those are technically chatbots, right? So I would say that the scope has changed a bit. Initially, it was mainly for B2C customer service, sales, marketing. But now it's becoming more and more domain-specific in domains like finance, insurance, entertainment, news, health, and so on. And this is the main advantages of going with a chatbot. First is cost reduction, meaning that you don't need to have a human presence during online interactions, right? So you can provide 24/7 support. So it's very well suited for repetitive queries that do not require any decision making. So it really removed the pressure on your support teams or call centers, etc. That's one advantage. Other one is user experience. You could say that some users, they find it more intuitive to interact with a chat rather than going through the menus of the application. And last point is that it can help attract new clients by providing personalized content. It can make prospective clients more likely to open an account or use a service. A bit of history. This is really just to show you that the concept of a chatbot is not new at all. And actually, we can date it back from 1950 with this paper published by Alan Turing called the imitation game, which is what we now call the Turing test. So this is when a machine has the ability to exhibit intelligent behavior that you cannot distinguish from a human. So in a sense, it's a criterion for intelligence. One of the first implementation of the chatbots is ELIZA, designed in the 1960s from the MIT. It was used as a medical tool for therapy sessions. It simply looked for specific keywords from a user's message and he offered a question back about it. So it's very simple but smart design. Keyword detection means it will trigger a rule, which will trigger a resulting sentence. And if the tool does not detect any keyword, then it will still provide either a generic response or something that it will repeat an earlier response. So basically, it always had something to say, no matter what. And at the time, it felt quite believable, and people were fooled by it. They were thinking they were actually talking to a human. Obviously, it was a bit limited, and sometimes it provided very comical answers, but still. Next one is Alice from 1995. That's the first version. So artificial linguistics internet computer entity. This one enables more sophisticated conversations with the help of natural language processing. So what is natural language processing? So it's the field at the intersection of computer science, artificial intelligence, and linguistics, which is the science of human language. The goal here is to enable computers to understand and communicate in human languages. So you know that there are thousands of spoken languages across the world. Each of them has its own alphabet, characters, syntax, grammar, punctuation, etc. And often you have many different ways to express the same concept, right? At the beginning, the NLP systems were using some sort of handwritten rules, and that proved to be not very robust, given the complexity of human languages. So it was very basically, it was a simple decision tree with some complex if, then, else kind of rules. Yeah. Now the NLP systems, they rely more heavily on machine learning and statistics, thanks to the rise of computational power, meaning that they are more able to automatically learn rules by analyzing a large corpus of real-world examples. This is just to expand a bit on the definition, right? When we talk about natural language processing, actually it's two distinct fields, natural language understanding and natural language generation. So we have text analysis and speech recognition, and on the other hand, text generation and speech synthesis. So what are the applications for doing NLP, apart from chatbots? First one might be machine translation. So the goal here is to provide accurate translations that can improve over time, as opposed to the one on the picture. Other use case is sentiment analysis. So this is how we identify, extract, and quantify affective states from a text input. It is useful usually for companies who want to collect feedback on their product from social media, tweets, or customer reviews, etc. And then you have things like question answering with speech recognition, information extraction, and information retrieval. So how do you do NLP? What are the main available techniques? Well, first of all, there are many different frameworks that allow you to, that provide such features. Most of them are written in Python, with the exception of the one on the top from the Stanford University, which is in Java. And it's actually the one we use in our project. First technique is tokenization. So it means chopping a document or a sentence into multiple pieces or tokens. So you would think, okay, that's an easy task. You just need to split on a white space and throw away the punctuation, and the job is done. But actually, it's not that simple. Even for the English language, if you take this example, there's actually 4 different ways to achieve tokenization. So you need to select your own the tokenizer that suits better. This is due to how you handle punctuation, like in the word in the middle. And okay, keep in mind that this is just for the English language. But what about languages that do not have punctuation or white space, like in Thai, for example? How do you extract tokens from this sentence? It's not easy, right? Try to think about it. How do you actually map this to individual tokens that you can use later? It's not a straightforward job. And another example which I like is Turkish language. Actually, you have the same in German, I think. So you have a sample word, like the one at the top, and you can keep on adding suffixes to it, and it will every time add another layer of meaning. And in the end, you end up with like crazy-looking words like the one at the bottom, like 70 characters. Yeah, how do you parse such a word? How do you tokenize it? Then I want to talk about sentence boundary detection. So this is simply meaning how you detect where a sentence starts and where it ends. And again, in English language, it sounds like an easy job, but because we know that sentences, they start with uppercase letter and they end with a period or like an exclamation mark or question mark. But even in English, it's not so easy. It's actually ambiguous. For example, a dot or a period can appear in an abbreviation, ellipsis, or a decimal point. So you need to have some sort of dictionary of all the possible abbreviations for your language. Next one is lemmatization and stemming. Stemming is reducing some like a set of words to their root form. Yeah. And lemmatization is actually quite similar. It's just that it maps different derived version of a word to a single dictionary entry. This is what a lemma is. So part of speech tagging, it means putting words into categories. So in English, there are 9 different categories, like a noun, a verb, adjective, adverb, preposition, pronoun, etc., this kind of thing. And each of those categories, they have a subcategory, which means that part of speech algorithm, they need to know basic grammar rules. Because some words, they can have different meanings based on the context. For example, the word book can be either a noun or a verb, right? So you need to have some sort of context. Chunking means grouping small pieces into bigger pieces. So building a parse tree of your sentence. And this relies on grammar rules. For example, in English, a sentence is typically made up of a noun phrase followed by a verb phrase. Yeah? And a noun phrase can be an article followed by a noun or adjective followed by a noun, this kind of grammar rules. So it's very language specific. And this helps you finding relationships between the different parts of your sentence. And the last one, it's maybe the most important one, is named entity recognition. This is when you want to locate and classify entities, like a person, an organization, a place, a date. Could be anything, could be, I don't know, an IP address, a percentage, a quantity, anything. So the frameworks, they provide you with default entities, like the one at the bottom. But obviously, if you want to build a domain-specific NLP application, then you will need to train your own model. Which is actually what we did at the Singapore Stock Exchange. So a bit of context, SGX as a financial institution, it provides public information about its financial product, like stocks, derivative products, indexes, and so on. All of those are publicly available. If you go to sgx.com, you can have a look at what the data looks like. The motivation for building a chatbot is to improve user experience in the retrieval of information on those products, and then to increase visibility on the SGX product. And eventually, the goal is to allow traders or brokers to place orders through the chat tool. So SGX is a major exchange for the trading of futures contracts on commodities, things like oil, gas, or mining product like coal or iron ore, this kind of stuff. So that's our use case. Let's take this sentence as an example. Let's say we have a user requesting through the chatbot the daily settlement price of iron ore futures contract expiring in 2020. That's just an example. But for the chatbot to be able to fulfill such a request, we need to extract different things, like the type of requesting information, the settlement price in this example, the contract code, which is iron ore, and the contract date, June 2020. So those entities, they are very domain specific, meaning that they are not available out of the box in any of the NER, name entity recognition frameworks. So how do we teach our chatbot what is a futures contract? What is a daily settlement price? So that whenever a new request comes in, like something that he has never seen before, then it is able to detect the entities with a decent precision. So how do we do that? So keep in mind that we have dozens of different things that a user can request. We have hundreds of different products on SGX. Each of them has many different appellations or nicknames, right? So obviously we cannot hard code everything with handwritten rules. It would just not work. So we need to build a machine learning model. So this is supervised learning. So where we provide the model as many meaningful samples as possible in order to train it. First step is collecting samples. So here we need to discuss with our business stakeholders what are the different questions that users they might ask for. And obviously, the more data we collect, the better. For each of those sentences, for each of those samples, we apply tokenization. So we split everything into sentences, then we split each sentence into tokens. Then we apply entity annotations. So this is a very manual process, but for each of the tokens, we need to map them to existing entities that we have in our domain, like a type of information or futures contract code or a date. And that's a very tedious process because we need to do it manually for each of the data set, each of the elements of the data set. And obviously we throw away whatever we are not interested in. You can see the entity O means other, so like not detected. So once we have annotated everything, we apply a regular machine learning process or supervised learning process, where we split our whole data set into 2 different parts. One half for training data and the other half for testing data. It doesn't have to be half and half, it can be 80%, 20%, for example. Then we train our model. This is the step that takes most of the time. Actually, we use a dedicated machine for that with 16 CPUs and 64 gigabytes of memory. And you also have the options to rely on graphic cards like GPUs because it makes the computation faster. But even with like a powerful machine like this one, we need to be careful about how much data that how much training data we feed the system. If we are too ambitious, it might take days, weeks, or even years to complete. Right? This is what we call the combinatorial complexity. It's even worse than exponential. It's combinatorial, right? So let's say we have some reasonable training data, a reasonable amount of training data, and we manage to build the serialized version of the model within a couple of days, or maybe over a weekend, in like 48 hours. Then we need to test it. So we apply the testing data set on the model itself, and we deduce some useful metrics like precision, recall, F1 score. This is more or less the same thing. It gives you some statistics about the ratios of true positives over the whole data set. Yeah. So it gives you the degree of precision of your model. And this is something that you aim at improving over time. And actually, that's the last step, is do the same thing over again, improve, collect feedback from users, and repeat the whole thing. And here, I want to stress out that this heavily relies on human intervention. So there is no automation here. Like the chatbot does not learn and improve by itself. You know, it doesn't work like that. This is another layer of complexity that we do not have. So yeah, so as a few words of conclusion, at the end we have a chatbot which is capable of handling complex user requests. So we could say it starts to be smart or smart enough because it understands our domain-specific language, which is finance and derivative contracts. If you want to build a chatbot, like a basic chatbot, it's actually quite easy to do it and to integrate it with the available chat tools, like WhatsApp or Messenger or Slack. And if you want to do something more complex, you can rely on natural language processing. It gives you all the tools for you to translate human language into computer speak. All right, that's it for me. So I hope that you now have a better understanding about how to design smart chatbots with natural language processing. Feel free to get in touch. That's my email address, or talk to us at the Zenika booth in the main room. And feel free to leave a review on this presentation, scanning this QR code. Okay, thank you.